This proof is going to look a lot like the last one, so let's just go ahead and start with A, B, C, D, parallelogram. And they say prove the diagonals of a parallelogram bisect each other. So let's draw that. Let's draw some diagonals on a parallelogram, and let's see if they bisect each other. They better. We know they do. We're just going to prove it. So we'll know that they do. Okay. So in the end, we're going to say this is congruent to this is congruent to this, okay? And we probably need a point in the middle. We're going to call it E. You know, alphabetical. Why not? So let's start with what we've been given. And what we've been given is a parallelogram, ABCD, with an E in the middle. And so we're going to start by saying that we have a couple pairs of opposite sides that are parallel, because that's the definition of a parallelogram, right? And it's really where we need to go. Actually, before we write anything down, let's figure out where we're really going. Final answer on this one is going to be a statement that says, therefore, the diagonals of a parallelogram bisect each other. And we're going to get that from, hang with me here, saying that this equals this and this equals this. And I have an idea. Why don't we do the same process we did a minute ago? So take some of the similar thinking and prove that a couple of the triangles are congruent. Okay, so if we prove the triangles are congruent, then we'll be able to say, well, the corresponding parts are congruent, and therefore these are the same, and the diagonals bisect each other, okay? So let's go back to a different list, and that list is here. I've marked it out, parts of it. So we're going to try a few things. We're going to say, maybe we can try side, 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 angle, angle, or angle, angle, side. And let's try them. Okay, well, you're proving two triangles, top one, bottom one, this is what I'm dealing with, are congruent using side, side, side. No, because I'm trying to prove those things about the sides. So I can't use two sides. So I'm stuck with these again. I have an option, a lot of options actually, and I'm going to go ahead and start labeling some stuff. We can do that alternate interior thing again. We can go this with this. Feel free. Totally works. We can also, and this is going to be kind of a neat approach. Sounds exciting. Because this is equal to this, let's mark it, double swoosh it. That way it's not going to be confused with this, even though it's a different color. You know, got to be consistent. This is congruent to that because of vertical angles. And we also know, we've proved it, so we can use it now. We also know that this is congruent to this because opposite sides of a parallelogram are congruent. So once we've proven it, we can use it. So we don't have to back up and prove all that other stuff again. So let's jump in and we're going to do that. This looks like angle, angle, side to me. And therefore, we will jump in. Let's start by proving that these two are congruent using alternate interior. And before we really do that, we need to start with what they gave us. And what they gave us was the fact that we have a parallelogram. So BC is parallel to AD, and we know that because this is the definition of a parallelogram. And for that reason, now that we have that reason established, we can go to reason number 2 and say, well, I know that, therefore I know this. I know that angle CBE, we'll use the E, is congruent to angle ADE. I know that because alternate interior angles are congruent if you have parallel lines, okay? Number 3. Okay, now we're building our way to eventually having angle, angle, side. So far we have established this angle. Let's establish an angle and a side. Let's pick one. Let's pick a side. I'm going to say that BC is congruent to AD, and I know that because, here's our reason in red, we did this a minute ago, opposite sides of a parallelogram are congruent. Opposite sides of a parallelogram, ooh, it's an ugly parallelogram, are congruent. Okay. Let's get that angle now. Angle AED is congruent to angle, okay, let's match up the parts, CBE. And I know that because, here's our reason in red, we did this a minute ago, opposite sides of a parallelogram are congruent. Opposite sides of a parallelogram are congruent. Okay. Let's get that angle now. Angle AD is congruent to angle, CBE. And I know that because E, B. Now I can't just call it angle E. We have a lot of angles going on here at E. I can't just call it that, right? So basically I know this angle is equal to that angle in its measurement because vertical angles are congruent. Vertical not meaning up and down, but vertical across from each other in that context, in that configuration. Vertical angles are congruent. Okay, we have just said everything that's on our picture. We've proven angle, angle, and a side. So now we're going to say, well, you know what? I got angle, angle, side going on. Why don't we go ahead and do this situation? But let's match up the corresponding parts. So triangle A, D, E is congruent to triangle C, B, E. And I know that because of angle, angle, side. Well, because I know that, guess what else I know? I also now know that corresponding parts of congruent triangles are congruent, and therefore I can say that this is equal to this, and that this is equal to this in measurement. And therefore I can say that the diagonals of a parallelogram bisect each other. Oh, okay, so let's do it. AC is congruent to, AE, I should say. AE. Let's make that look more like an E. AE is congruent to CE, and also BE is congruent to DE, and I know all of that because corresponding parts of congruent triangles are congruent, and now we're done once we write our final statement. Therefore, the diagonals of a parallelogram bisect each other. Yeah.